Okay, so what we're doing when we solve exponentials, especially when they look like this, is we're trying to get our bases to be the same. So those are the large numbers when we see the exponents. So here we want the 8 and we want the 64 to have the same base. So we want to see how can we rewrite one of them to where they both will have the same base. So typically, not all the time, but typically you want to start with the larger number and try to make that into a smaller base. So for example, the 64, well, we want to try to write it with a base of 8. So we're trying to see 8 raised to what power gives us 64. Well, that would be 8 squared. So what we can do is we can take the 64 and we can rewrite that as 8 squared, and we'll leave the other side alone. Now, since we have the same bases now we can ignore the bases and we can look at just what's in the exponent. So we're just going to set 4x plus 2 equal to 2. And we're going to solve from there. So we subtract 2. 4x equals 0. And then we want to divide both sides by 4. So we get x equals 0. Okay, so same thing here. We have 5 raised to the x minus 6 equals 125, so we do want to change the 125 in this case. So we want to see 5 raised to what power gives us 125. So 5 squared would be 25, and if we multiply that by another 5, that would be 125, so it would be 5 to the third. So what I'm going to do is I'm going to rewrite this 125 as 5 to the third, and we'll keep the other side the same since it's already got a base of 5. So now since we have the same base, we can ignore the base part of it, and we can look at just what's in the exponent. So then we want to solve from there. We had 6, and we get x equals 9. Okay, number 3, we have 81 raised to the x plus 2 equals 3x plus, or 3 to the 3x plus 1. So again, we do want to keep our bases, or get our bases to be the same. So again, we want to typically rewrite the larger base as a smaller one. So if you don't know 3 raised to what power gives us 81, you can always do a factor tree. So as long as you know 2 numbers that multiply to give you 81, you don't want to use 1. Anything else, so will be okay. So like 81 we know is 9 times 9. Well, 9 is not 3, but we do know that 9 can be broken down to 3 times 3, and this 9 can be broken down to 3 times 3. So if you see, we have 1, 2, 3, 4 3's. So 81 is the same thing as 3 to the 4th. Oops. Now, when we do change that 81, what's going to happen is that it's only the 81 that becomes 3 to the 4th. Now, that's still being raised to the x plus 2 power. The only thing that changes is 3 to the 4th replaces the 81, but we still have that x plus 2 there. So in the previous 2 problems, we didn't have to worry about this, but this one we do. So when we have an exponent raised to an exponent, we got to multiply our exponents. So this 4, we need to distribute out to the x and to the 2. So we end up with 3 to the 4x plus 8. And then over here on the other side, we have 3 to the 3x plus 1. So now that we have our 2 bases the same, and we don't have any parentheses with the exponents, we can ignore our bases, and we can set our exponents equal to 1 another. So I'm going to get my variables on one side, so I'm going to subtract 3x on both sides. So on the left, we have x plus 8, and on the right, we have 1. So then we subtract 8. So x is negative 7. Okay, now number 4, we have 9 raised to the 3x plus 1 and 27 raised to the 3x minus 1. Now on this one, the way that the numbers are going to work out, we're actually going to have to change both bases, and sometimes that happens. So we want to rewrite the 9, and we also want to rewrite the 27. And we want them to have the same base. So if we think about breaking down both 9 and 27, they both have a factor of 3 in there, because 9 can be rewritten as 3 squared, because 3 times 3 is 9. And then 27 can be rewritten as 3 to the third, because 3 times 3 times 3 is 27. So we're going to change those two. So the 9 becomes 3 squared, and we still have that 3x plus 1 power. Now we're going to do the same thing with the 27, but we're going to replace it with the 3 to the third. And we still have that raised to the 3x minus 1. Now, just like the last one, we do need to distribute out the exponents. So like this 2, we get distributed to the 3x and to the 1, and this 3 gets distributed to the 3x and the negative 1. So I'm going to go ahead and do that. So we end up with 2 times 3x is 6x. 2 times 1 is 2. Then here we have 3 times 3 is 9x. Or I guess 3 times 3x. And then we have 3 times negative 1, which is negative 3. So now that we have all of the powers raised to a power taken care of, and our bases are the same, we can ignore the base, and we set the exponents equal to one another. So we have 6x plus 2 equals 9x minus 3. And now we want to get all of our variables on one side, so I'm going to subtract 6x. And we get 2 equals, that would be 3x minus 3. So then we want to move the 3 over. So we get 7 equals 3x, and then we want to divide by 3. Now on these, we can leave our answer as an improper fraction. That's perfectly fine. So x is 7 over 3. Okay, so number 5, the last one, we have 8 raised to the 2x plus 4, and 16 raised to the x plus 1. So kind of similar to how we had to change both bases on number 4, we're going to have to do the same thing here. Because there's no power of 8 that we can raise, well, I should say there's no even power that's easy to get of 8 that we can raise to give us 16. So here we want to change both of our bases. So if you don't know what the base that we're going to try to change these both to be base 2, that's okay. You can always use the factor tree to help you determine that. So if I took 8 and I broke that down, that'd be 2 times 4. Well, 2 is a prime number, so we're done there. 4 we can break down to 2 times 2. So 8 is the same thing as 2 to the third power. So that's what I'm going to rewrite 8 as. 2 to the third. And then we got to still keep that 2x plus 4 power. So we're going to do the same thing with the 16. So we can think about 16, that's like 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. So we have 1, 2, 3, 4. So 2 to the 4th is 16. So we're going to replace the 16 with 2 to the 4th. And we keep our exponents up here. So just like the other ones, we do need to distribute out our exponent. Oops. There we go. So over here on the left we have 2, and then 3 times 2x is 6x. 3 times 4 is 12. Then over here, 4 times x is 4x, and 4 times 1 is 4. So now that we have our bases the same, we can ignore the base, and we can just set our exponents equal to one another. So we want to get our variables on one side, so I'm going to move the 4x over by subtracting it. So we have, that ends up being 2x minus 12. And then over here, that goes away, so we're left with 4. So we'll add 12. 2x equals 16. And then divide both sides by 2. So x is